All right, I'm going to go through a couple of examples of how to graph a sine or a cosine curve with all the different transformations we've talked about already. So change in amplitude, phase shift, midline, and a change in frequency. So the first thing you'd want to do if you see a function like this, you might notice that the frequency is 2. But in order to see what the horizontal shift is, I'm going to factor that 2 out from those parentheses. So I'm going to rewrite this function as y equals 3 sine of 2 times x minus, and then you got to think, what would I multiply 2 by to make it so that there's a pi in the parentheses there? Well, we got that x from dividing the 2x by 2. So if I divide pi by 2, I could make that pi over 2. And of course, you could check in your head by redistributing and make sure you get 2x minus pi. And then there's that vertical shift of plus 1 at the end. So the amplitude for this function is just going to be 3. So that's how far I'm going to deviate from the midline. And our midline corresponds to whatever our vertical translation is. So that's going to be that plus 1 at the end there. So usually, just to give myself a range of values, I like to go to y equals 1, just dash in that midline there so I know to keep returning to that for a sine curve. Because I know a sine curve starts and ends on its midline. So I could label that as like 1. And then if my amplitude is 3, that means I'm going to go at most 3 units up from that and 3 units down from that. So my range for this function is going to go from forward and negative to nothing outside of those bounds. So now, if I see a minus pi over 2 there, that's talking about my phase shift or my horizontal translation. Remember, subtracting something from your input is going to move it right. So my function is going to move right pi over 2 units. That means that's where I should start my sine curve rather than starting it at 0. But I want to think about my frequency and my period first before I start trying to scale the x-axis. So my frequency is just 2. That's the number being multiplied to the input there. And remember, to find your period, you can take 2 pi and divide it by whatever your frequency is. So the period for this curve is pi units. So what that means is any distance of pi on the x-axis should show 1 complete cycle of sine here. So to think a little bit, I'm going to plot 4 important points after the starting point. So each of my tick marks on the x-axis after where I start should be a fourth of my period away from each other. So if I, let's say, go out 1, 2, 3, let's make that 4 boxes for pi over 2. I'm establishing that every 4 boxes is a distance of pi over 2 units. So my next tick mark can't be 4 boxes away because I know that all of my tick marks are going to be pi over 4 units away from each other. So to figure out what to label them, I know it's going to be right here, right here, right here, and right here. And I know that because pi over 4 is half the distance of pi over 2. So every 2 boxes, I'm in a tick mark. To find out what those next ones are, I would just take pi over 2 and add to it pi over 4. Now, it's helpful to think about these as equivalent fractions. So rarely would I think about that as pi over 2. I would think about that as 2 pi over 4 in this case. So my next tick mark would be occurring at 3 pi over 4, right? 2 pi over 4 plus pi over 4. If I add another pi over 4 to that, I would end up at 4 pi over 4, or I could reduce that to just pi. And then if I add another pi over 4, think about pi as 4 pi over 4, plus another one would be at 5 pi over 4, and then at 6 pi over 4, or 3 pi over 2 if I reduce it. So that's the setup. And in my head, I recognize that this is a sine curve. So I'm trying to picture something that goes up, comes down, and then returns to its midline. So I'm just going to plot that. I'll start at its midline at 1, go up to its maximum of 4, down to the midline of 1, down to the minimum of -2, probably should have drew those labels a little smaller, and returning to my midline. I'm going to try to draw this to the best of my ability. It doesn't have to be perfect, but it should look like a sine curve, right? It shouldn't have any pointy edges. It should be nice and smooth. Now, you'll know if you did this incorrectly because it should look roughly symmetric, where this part of the graph should look the same size as this part of the graph. They're both 4 units away from the midline for the max and the min, and it fits nicely on those axes. The biggest thing you got to worry about when you have a phase shift is keeping your scaling in the x-axis consistent, that this distance is the same amount as this distance right here, and I've ensured that because both of those are a distance of pi over 2. So that's an example of a sine curve. Let's try one that's a cosine curve. So now I'm going to graph one full cycle of y equals -4 cosine of x over 2 plus 2 pi minus 1. I'm going to do the same thing I did for the last one, where I'm going to try to factor out that frequency first and hope that that can show me what our horizontal shift is. Now, if x is being divided by 2, and I want that to just be x, I can factor out a 1/2 from my x over 2, right? Because if I multiply 1/2 by x, that's the same thing as if I divided x by 2. And you got to think a little bit hard about this. If you're factoring out a 1/2, that's the same thing as if you're multiplying the inside by 2, because dividing by 1/2 is the same as multiplying by 2. So I think this inside part here would have to be 4 pi. And you could always check yourself. It's really easy to check. Just multiply 1/2 by 4 pi. Make sure you get what's in the parentheses there. All right, so I'm going to go through the same analysis we did for that last sine curve, where the amplitude in this case is going to be 4. Keep in mind the amplitude isn't -4, it's a distance, so it must be positive. That negative simply tells me I'm going to reflect this curve over the midline when I go to graph it. All right, so the midline should be -1, right? So it's a horizontal line, y equals -1. The phase shift is going to be now, if I'm adding 4 pi, that's going to be left 4 pi units. So I'm actually going to start to the left of the origin rather than on the origin or to the right of it like we normally do. And the frequency is 1/2, which means if I want to calculate a period, that would be 2 pi divided by 1/2. Now, keep in mind, when I'm dividing fractions, I could keep the numerator and just multiply by the reciprocal. So every 4 pi units, we are going to complete one full cycle here, which is pretty convenient if I'm shifting left 4 pi units. So that's often the case, even though for the last one, we had a bit of a mismatch of where our shift was compared to how our period fit in. In this case, I think it's going to fit pretty nicely. So my increment on the x-axis is going to go by 1/4 of whatever the period is. So every pi units, I'm going to make a tick mark. So let me space this out a little bit, maybe every 2 boxes. I'll make a tick mark, and I'm going to start at, I'll label it above the x-axis here, -4 pi. And the reason I'm starting there is because of my phase shift. Rather than starting at 0 or on the y-axis like I normally do, I'm translating this left 4 pi units. Now, if my increment is pi, that means the next important point is going to happen at -3 pi, -2 pi, -pi, and then at 0. So let me try to sketch in the midline and the range again, right? Midline in this case is at -1. So to establish the scale, I'm going to label that as -1. I am going to go at most 4 units up. That means 1, 2, 3, 4. I'm going to be up to 3 and down to -5 as a minimum. Now keep in mind, a regular cosine curve kind of looks something like this. But that negative out in front is going to cause a reflection over that midline. So rather than starting at the maximum, I'm going to start this curve at the minimum. So it's going to start at, let's see, -5. Then my next point occurs on my midline. My next point occurs up at my maximum, back down to my midline, and I'm going to finish off back down at my minimum. And again, try to connect this as a smooth curve the best you can. Ooh, yikes, I could have spaced that out a little bit more. But you get the idea. Right, the analysis is the exact same for a sine curve, only for a cosine curve you picture something different in your head, and you start at either your max or your min.